Hey, everybody. Thank you so much
Hello.
for spending the time with us here at AWS reInvent to listen to Nvidia and Cohesity talk about how we can help accelerate business decisions with RAG and artificial intelligence. We're going to kind of run through a brief agenda. What we're going to do, we're going to introduce ourselves, and then we're going to jump straight into it. So, first we're going to talk about, why RAG is so hard at scale in the enterprise. We're going to talk about how Cohesity and Nvidia have partnered together to really simplify this and accelerate a lot of the time to value that customers can expect when bringing generative AI capabilities to the enterprise at scale. Then my friend Nabe here is going to spend some time talking about Nvidia's Nim and Nemo architecture, which really helped make a lot of this possible for us. And then we're going to talk about something near and dear to my heart, which is Cohesity Gaia, the ability to bring generative AI capabilities to vast quantities of data, re-leveraging assets that you already have to drive incremental value to your environment. Speaking of us, my name is Greg Staton. I work in the office of the CTO, responsible for our data and AI strategies and initiatives at Cohesity, and I'm joined by
Navel Garisi. I'm a product manager on the Nvidia generative AI team, focusing on Nvidia inference microservices as well as Nemo Retriever, connecting large-scale data to generative AI.
Well, let's go ahead and get started. We said that we were going to kick this off by talking about the challenges that people are going to experience when bringing generative AI capabilities to vast quantities of data. So Nabe, do you want to help take the team through? I'll pass the baton to you.
Yes, absolutely. Thank you. So at NVIDIA, we've been working across the board with enterprises on deploying RAG at scale. Everybody's doing it. Everybody should be doing it. And we want to make sure that the ecosystem is successful. What are the common challenges that we've been seeing throughout the partnerships and use cases that we've been engaged on? First of all, number one objective for deploying RAG and deploying RAG successfully is getting to the accuracy level that is sufficient for the business use case. You're looking to provide value to the end user, and for that, you need to make sure that your data pipelines and your generative AI accuracy, LLM, retrieval, whatsoever, is at the level that you need it to be. Second is maintaining it within your ecosystem. And moving data in and out of your platform is one of the key challenges and key restrictions for many enterprise use cases, so ensuring that everything is stored within your private network. Third, is complexity. Building these pipelines now with introduction of agents and tool use and a bunch of other connectors, it's becoming very complex. And simplifying that and reducing the overhead of deploying models, orchestrating models, and additional parts is what we are focusing on at NVIDIA. The cost is a constant, constantly in our thoughts. We're thinking about how to enable large-scale data ingestion and processing, as well as generating a bunch of LLM inference workloads. And finally, innovation. This space has been moving so fast. Just over the past 10, 11 months that we've been working together, the space has just been amazing, and we've been updating ourselves. We've been listening to the ecosystem, to our customers, what they're asking for, and the goalpost keeps moving ahead, which we love. And one of the key reasons why we're on this stage here with Cohesity is we found this big opportunity for processing these large-scale databases. We're talking about exabytes and exabytes of data, and connecting them to the generative AI applications and bringing them to this era. And to do that, we have a lot of technology to share with you and a lot of cool new techniques that we've been working on together.
Real quick, Nabe, I think, looking back at some of the challenges that you pointed out here, and if your guys' LinkedIn feed is anything like ours are, everybody's talking about how you can deploy RAG in 10 simple lines of code, or pull this one GitHub repository and unlock unprecedented insights. And it's great, and those are cute because they work really well on like 5, 10, 15 documents. but I don't know a single enterprise that operates on 10 documents, maybe 100,000, maybe 10 million documents. And these sorts of tools don't ever scale to that order of magnitude. And I think that's why it takes a collaboration between an enterprise data management company that operates in the hundreds of petabytes under management per customer, and a company like Nvidia who brings the accelerated AI to the data. It's kind of a match made in heaven. It's a peanut butter Nutella situation, really.
And the colors match, so that's another bonus.
It was really good. You can laugh, it's okay. I want some better laugh track.
For the recording, yeah.
That's okay.
All right, let's go into it. So, the first step of a good RAG application starts with the R, which is retrieval. And that is one of the core focuses of our partnership on thinking how do we scale both data ingestion and retrieval. And on the Nvidia side, we have been building an ecosystem and tools that we call Nemo Retriever. So Nemo Retriever is a set of microservices for deploying, customizing, and scaling retrieval. And that includes both text embedding for taking large chunks of text and creating a vector representation of them to store into a vector database, which is the new form of data storage, as well as text re-ranking, taking the retrieved chunks based on a query that you asked the RAG pipeline, and then rescore them based on the relevancy to the query, which is a critical step to reaching these high accuracy pipelines that we're talking about. All this together, we are delivering through what we call NIMs, NVIDIA Inference Microservices, which are optimized inference engines, basically building all the NVIDIA software that we have inside a container or a box that you can download and deploy wherever you like, if it's on AWS, if it's on-prem, or if it's in a hybrid environment. And what we want to make sure that wherever you deploy, you get the enterprise support you need, the scale, the performance, and as long as it's running on an NVIDIA GPU, essentially.
No, and when people are talking about generative AI, and especially in the enterprise, everybody wants to jump to the foundational models because they're exciting. They mimic the fluency of humans, but they're only going to be ever as good as the data that's fed. And I think the information retrieval pipeline, which is kind of what's shown here, I think is even more important than spending time on what size of a parameter LLM foundational model you have. This is the core foundation of your enterprise data strategy, is a robust information retrieval system.
Absolutely, yeah. Yeah, so a little bit more about why this is such an amazing work. So we have an extensive team of researchers and developers that are both focusing on the modeling side, creating state-of-the-art models for retrieval and RAG, as well as engineers that are focusing on optimizing the pipelines and the model inferencing for these large-scale deployments. So one of the common ways to look up and evaluate embedding models for retrieval is called the MTEB leaderboard. It's an open source community leaderboard, and our team at NVIDIA have been at the top of the leaderboard in a continuous way through multiple models over the past six-ish months. On the inference side, we've been very much focusing at scale, how to take large batches of data and index them into a vector store very, very fast, as well as retrieve them very, very fast at scale. And that's through a library that we've developed called QVS, CUDA Vector Search, which is getting integrated into the existing vector search applications like Milvus, Face, and more. Now, a little bit more about the NVIDIA Inference Microservice. So what you see here is the core value of a NIM. It takes the model that holds a lot of value, delivers high accuracy, and packages it in a way that ensures high throughput, low latency, and easy scalability. Right? So you see the value of throughput increase when you deploy with a NIM versus without a NIM, as well as what it happens to the accuracy once you use the NVIDIA models. We're also working with ecosystem partners outside of NVIDIA to deploy their models as part of the NIM ecosystem, so partners like Cohesity and others can deploy whichever model is best for their customers and their use cases. So that flexibility is very important. Another point is customizability. We understand that many use cases have specific domains or specific jargon that needs to be included as part of the embedding space to basically ensure high accuracy. So all these models are customizable and deployable via the same NIMs and the same pipelines. And how all this is coming together is what we call a blueprint. So these blueprints basically show you how to, this is basically a reference architecture on how to connect all these NIMs and components, both from NVIDIA and third party, into a pipeline that you can actually use in production, customize to your own use cases, and deploy. And what you see here is both an ingestion pipeline for multimodal PDFs. Multimodal PDFs, we mean PDFs that contain more than text, like charts, images, graphs, and tables. So all of that is getting processed through a series of models that each of them have a job and ensure high accuracy in their respective domain. But at the end, you get a parsed PDF that you can use for the retrieval and RAG downstream tasks. All of that is getting funneled into the embedding for storage, and then in retrieval gets matched to the embedding of the query, re-ranked with a re-ranker model, and fed to the LLM NIM for generating an answer. So all of this together, you think about it as the individual components that are extremely optimized, and as well as the pipelines on how to do large-scale embedding plus indexing, how to do efficient PDF extraction. All of that is getting optimized by NVIDIA and shared with Cohesity and partners for them to deploy and enrich their ecosystem and solution, essentially.
No, these blueprints were critical in how we designed and architected our solution. Our solution right now, we'll get to in a little bit, runs in AWS, but because of the blueprints that have been provided by NVIDIA, this allows us to seamlessly bring this on-prem and run them where the data exists. This allows us to be able to surgically place in the components or the individual NIMs that are going to be best optimized for the type of data, type of workloads, type of industry. And it provides the most flexibility and most repeatability, I think, is another huge benefit, especially when you're talking about AI. Repeatability is key.
Yes. And what's good about these is they're getting continuously refreshed and updated, right? So any new advancement, be it in the model space, in the pipeline optimization, we're doing a lot of optimization around data processing and introducing a lot of the traditional ML optimization pipelines into the RAG space. All of that with customization tools and other cool things are getting updated into these blueprints and continuously published. So you can always keep up to date with the latest NVIDIA technologies and integrate those into your solutions. And if you want to get started with these NVIDIA technologies, you're welcome to do so. They're all publicly available. One core place to look them up is through our preview APIs on build.nvidia.com, build.nvidia.com. And this is our API catalog where you can find both our blueprints as well as our NIMs that you can use as an API or download for on-prem deployment or cloud deployment. We're also in most of the CSP providers and as well as AWS. And another place, if you want to learn how to use these NIMs and these blueprints, is NVIDIA Launchpad. This is a closed web offering that you can engage with our NIMs and get a head start, basically, on how to use and deploy NIMs. Now I'll pass it on to my friend Greg to talk more about.
Yeah, and one thing that we learned early on is we started to build out our retrieval augmented generation pipeline on our own as we were kind of initiating the engagement with NVIDIA. And one thing that we learned is to deploy it, pretty simple. To be able to optimize those models to most efficiently use the hardware available to it, to reduce the amount of latency, to optimize for the number of transactions per second, which then also reduces that, that overall cost per query, that cost per inference, and really tune that model is where the advantage of the NIMs really came into play. We could have spent the time and the engineering resource hours to kind of figure out the optimizations, but by the time that we did all that, a new and better model would have been released and we would have been right back to the beginning. So with NIMs, and I highly suggest that you start to kind of play with them to get a feel for them, it really takes all of that complexity out of the equation when trying to optimize any sort of model for the particular piece of hardware that you're running on. Because I mean, let's face it, GPUs, they're not inexpensive. And so when you do buy one to use for a particular use case, you want to be able to squeeze every ounce of performance out of it, and that's what you're delivering with NIMs.
That's right, and we are currently always pushing the boundaries, right? There's not, the value that you will get from your existing hardware is going to get more and more. And as we move forward, we're optimizing the NIMs, optimizing the models, and it's only going to get better.
Yeah, I really can't wait. So now that we're gonna, we learned a little bit about NIMs, we learned a little bit about the blueprints and kind of a little bit more about retrieval augmented generation. Let's talk about why Cohesity, a company that was known as a backup company at one point in time, what we're doing in this space and why we're standing on the stage next to titans like Nvidia here. For those of you that don't know, and I normally ask people to raise their hands if they've heard of Cohesity, but I can't see you all right now because of the light, so I'm just going to assume that nobody raised their hands. Cohesity released we call the Cohesity Data Cloud. And this was traditionally stood up by 4 main pillars: data protection, data security, data mobility, and data access. We built this company off a robust, infinitely scalable distributed file system. It's very important to understand that we built this file system to run these distinct workloads. Our founders and a lot of us from the early days of Cohesity were raised on the core tenets and beliefs of hyperconvergence, being able to bring workloads close to the data. So we built this file system with that in mind. And so the first workload we brought to the system is data protection. This is backup, the ability to take every single enterprise application and back it up onto an infinitely scalable platform. This can be on-prem, this can be in the cloud. Doesn't matter. This is all software and runs on-prem in a customer-managed VPC or consumed as a service in AWS. And we optimized this backup. We started rolling out more and more workloads on top of this. The next thing we did is we wanted to start re-leveraging that data asset that we're protecting to drive other efficiencies. And this is going to be a common theme across this talk here. The next thing we did is we said, hey, this is the enterprise data of last resort. We need to protect the integrity and resiliency of this data for when it needs to be used to reestablish or reinstantiate an application, or when your boss deletes an email. So we released a data security suite of tools. What this does is this uses that backup stream to first check for anomalies, to be able to say, hey, is there any sort of anomalous behavior that we can identify in the incoming byte streams that are landing on the platform? And we use some pretty interesting AI models to be able to do that. The next thing we do is we give customers the ability to scan that data and do data classification on that. Because when there is an anomaly, we need to see what the impact is. We also enable threat hunting to be able to identify that threat that happened on the platform. And we also enable cyber vaulting to be able to send that data off disconnected from the environment. So in the event that everything is down, you have that recovery path. But again, the most important part of that pillar is that we're re-leveraging that asset that we're using for data protection to now drive data security. Now in the backup world, there's an adage of 3 copies of data, 2 locations, and 1 being offsite. And so we needed an efficient means of moving that data no matter where it needed to be on the planet. And so that's what data mobility is. Since again, we own the file system, we know what data needs to be placed on different locations to be able to ensure that we can recover that anywhere that needs to be recovered. And speaking of recovering, we need to be able to access that data. We need to be able to access it from any point in time, from anywhere on the planet, and be able to provide 0 performance penalty from doing so. If I'm accessing it from a minute ago or from 10 years ago, I should be able to access that. And again, this is all re-leveraging that asset that we used from the backup. We took a step back and said, this is more than just backup. we've created, by ingesting all of that data and collecting all of this metadata now about that through these different workloads, we've created a digital twin representation of the entire enterprise. We can enable our customers to further re-leverage that asset to drive a much more operational insights and intelligence through a pillar of data insights, bringing that data safely, securely, and responsibly with generative AI, as well as AI and ML workloads to drive unprecedented insights from this data. So what we're going to do is talk about how we leverage the Nvidia Nim ecosystem to develop what we call Cohesity Gaia, which is the first offering in our data insights pillar, which again re-leverages that data asset to drive operational efficiencies. Nave just talked about retrieval augmented generation and really breaks down into two main categories. There's information retrieval and there's generation. Our goal is to build the most robust enterprise information retrieval platform on the planet and have it be powered by NVIDIA. What we do is we enable administrators on the platform to go into their assets that are stored on the platform, be able to select sources and select pieces of data, wrap it and create what we call the data set, send it through that indexing pipeline that Nave was talking about, apply fine-grained role-based access control mechanisms on top of that data, and store it to be able to be used with large language models in a generation. This is great for a whole host of use cases, which we'll talk about in a second. But this architecture diagram essentially shows what happens. A user can come in, select a data set that they're interested in gaining deeper insights from, and we have a demo that we're going to play for you here in a second. It'll go through all of that data, find the most relevant chunks of information from those data files, wrap it inside of a large language model prompt, send it safely and securely over to a large language model to inference, return back an answer along with citations and resource links back to the files. And this is all push button simple. And it's already reusing the data that's being managed by Cohesity, whether it be in the cloud or on-prem. And so with Cohesity Gaia, we're simplifying insights, and I always like to say safely, securely, and responsibly, because I think people get a little scared when they're talking about bringing enterprise data to language models. And I think one thing that we at Cohesity do is we take the security and integrity of data very seriously. That data that's living on the platform is fully immutable. You can apply fine-grained role-based access control mechanisms on top of that, and you can have it adhere to your company's data governance policies. But really what this does is this starts to really vastly improve decision-making speed and accuracy, bringing kind of that AI-powered conversational search assistant to your high-quality enterprise data. The one thing that I really like to tell people is when your boss comes in and says, hey, we need some sort of generative AI initiative to tell the board that we're making progress. If you're a Cohesity customer, all this is an enablement of a SKU, and you're able to deliver some really interesting use cases on day zero with push button simplicity. This does boost AI initiatives.
Yeah, and to add to what you're saying, right? If the previous paradigm was your data is stored in one place, managed in one place, and your AI is in a completely separate place. You need to copy a bunch of documents in a secure, unsecure way to a vector database and use that, maintain the connections, maintain the refreshes, the versioning, all that fun stuff. That pipeline is broken, and it's meant to be broken so these pipelines can exist, right? So we're bringing the AI to the data versus the data to the AI. And that's the key value, right?
Yeah, I mean, and this relies on that core tenets and beliefs of hyperconvergence, bringing those close together. Data has a lot of gravity. Mm-hmm. And so bring the AI to the data and federate it across there. But with Cohesity Gaia, you can streamline those compliance and risk management. The pesky auditors and the pesky CISOs in your organization, they're going to want to ensure that the data is only being used by those who are allowed to use it. So this allows you to place fine-grained role-based access controls on top of those collections so that not anybody can go start asking questions on the CEO's mail. We talked a little bit about the high-level architecture diagram. Here's a little bit of a double click into what we've deployed now in AWS. With our backup as a service offering, it's broken into a control plane and data plane. And our control plane, that's our management UI. This is where you go in and set up your protection policies. This is where you can kind of do recoveries from. And this is also where you can go in and enable data set creation for generative AI use cases. And so what happens here is when an administrator goes in and say they want to create a data set, and you'll see this, and you'll see the results of this in a minute. They go through and select the data files or the backups that they are interested in. What happens next is that call gets pushed down to the data plane, and it finds where all of those backup files and the raw data files exist, no matter where they are on the planet. It will find those individual files, fetch them off, and send them to our indexing pipeline. And this is where we're heavily leveraging the NIMS and the Nemo blueprint reference architecture, where we can go through, because Cohesity owns that file system, we have the ability to access any file from any point in time, serve it back out in its native format. We then do text extraction from these files. We then do optimized chunking. We do a very efficient embeddings calculation, and then we store this on a vector database that's running inside of our data plane instance. So all of this is kept within the same security confines of the rest of your backup data. And these are also co-located with wherever the backup lives. So we're never having to, like Nave was saying, send this somewhere else. There's going to be localized vector stores and indexing services next to the data. And these get federated across when you're searching. So you don't have to send everything with long latency times to be able to interact with it. You can operate on it as if it's right there. And this is essentially what we've deployed. A user can interact with it. They're going to then query. And then on query, what happens, and this is the demo that we're going to be able to show you here next, user's going to ask a question. They're going to select their data set. What we do then is we take that input query, which is raw text or corpus, a small corpus. We compute the embeddings for that, and then we do a similarity search. We cast a wide net across the vector index and retrieve a lot of chunks of information that are co-similar to the user input text. We then take that list of vectors. We then pull the chunks of text out of the archive to make sure that the data is kept safely and securely. We then take that large list, we send it off to the Nemo re-ranking service, and we then pull the most relevant chunks, send it off to the language model, and then generate the answer and send it back to the user. I think what we're going to want to step through here is a demo. I usually like to tempt fate with the demo gods, but not here and not today. So I have a pre-recorded demo. It has a voiceover. I can pretend to ventriloquize myself to make up a word. So please take a watch of how you can use Cohesity Gaia.
All right, so we talked a lot about Cohesity Gaia and what it can do to help revolutionize your access to enterprise data in new and exciting ways. Now let's show about a practical situation. Imagine that you're working in a large enterprise and your senior leaders come to you and say, hey, we need a detailed breakdown of everything that happened in this unauthorized data breach in 2018 and 2021, all the policy changes that we've put in place since then, and like how that would help protect us going forward. You know, we need to be able to present our plan up to the board of directors here shortly, and yada yada yada. You have to do a lot of work, but you have to go run to another meeting to kind of brief them in the next like 20 minutes. You have a lot of the tribal knowledge from this because you sat through those events. You understood the implications and what happened during those events. But now you've got some folks working for you that haven't been around since then. They don't have that institutional knowledge. And it's all locked away inside of documentation and briefings that are in the archive. So what you do is you spin up a quick data set through Cohesity Gaia, connect to that archive, create the semantic aware index, and you give it over to one of your new hires, your interns, to be able to start collecting and collating that information so that you can take it, resynthesize it down into documents that you can present out. And so you've given this index to your new hire who was not around in 2018 and 2021, and you explain what's needed and say, hey, I need a detailed breakdown of those two events and all the policy changes that happened between them. That data set was created from the archive that was already backed up in Cohesity, and now they can go through, since they've been provided access to it, go through, find it, select it, and start asking away. And so the very first question that you're going to ask is, can you summarize the differences between the unauthorized data breach that happened in 2018 and 2021? We're going to remove the company names from this because these are actual documents. And so what's happening now is, because we created that semantic aware index, we're taking that input question and we're comparing against all of the pieces of data that was in that archive to find the individual paragraphs of text that are semantically relevant to this question. That we're going to use that to wrap inside of a prompt to send off to the large language model, which is then going to come back with an answer. And so here you can see that the large language model is now detailing the unauthorized data breach in 2018, detailing the unauthorized data breach in 2021, and it's going to kind of compare them and talk about the differences. And what's nice here is all of the data that is used to help answer this question is stored securely and safely and immutably on the Cohesity platform, and is only used and fetched at query time to be able to help the large language model answer the question. So this data is sent off, the answer is being generated, and it comes back to them. And the beautiful thing about this is, not only does it give you the answers, but it's also going to give you the documents that were used to kind of help create this summary. And so I can see here the individual documents that are used. And now, I need another little piece of information. They really wanted to know about those process and procedures changes that were implemented post that 2021 breach. And again, we're removing the company name. So it's going to take bits of my chat history plus that semantic aware index again, and use that to help answer the question. So it's going to go back, fetch all of, again, those relevant pieces of information, wrap them inside of a large language model prompt, send it off to the LLM, and the LLM is going to come back with a very fluent, detailed response. And so here it talks about the core procedure changes that are implemented at Company X to help protect themselves from future data breaches. And this is going to be very important when it comes to making sure that future breaches don't happen. The company's protected. Things like for updated and enhanced forensic investigations, customer support notifications, tighter integrations with legal and regulatory cooperations, it's specific financial provisions, etc. And one last question, this is going to help really summarize the whole thing for you, is, would any of those process changes made post 2021 breach been made any sort of impact to prevent that 2018 breach? And again, what it's going to do is it's going to use my chat history plus all of that data to be able to go forward and just help create my answer. So once this is all done, I can take all three of these answers plus the related documentation, put it together in a document, and to be able to present it back out to my boss and to the board. And in order to get to that, I can just select the individual documents, which are going to bring me over to the individual single file recovery screen within Cohesity Helios, and it's going to start downloading this document so that I can actually fetch and recover that. And then what's nice about this is, because those data files are coming from the backup, it is a known fixed point in time, so I know all of that data is consistent with each other from that single point in time of the backup. And this is also really helpful, especially when those documents no longer exist in production. Oftentimes it does have to go into the backup and into the archives to be able to fetch that, whereas pulling it from cheaper storage. And this is really a practical use case of being able to use generative AI capabilities along with data stored safely, securely, and responsibly inside of Cohesity to help you in your day-to-day job.
All right, so now I think that was a really neat way to kind of show how you can use generative AI plus your historical data to help drive operational efficiency. This breaks down those silos of tribal knowledge within an organization and to help rapidly onboard new employees or bring people in cross-functionally to help organizations.
Maybe you want to share some news from the past couple of days?
Thank you very much, Nave. And I think stepping up here, I was blinded by the light, and I had forgot that Cohesity was actually awarded Storage Partner of the Year from AWS. I think you guys can applaud louder than that. Yeah, I want to be able to hear that. No, it's something that we're extremely, extremely proud about. And then there was also one other announcement. You guys can go search this up and find there's a nice fun blog about it. But we launched the integrations of the Nemo re-ranking service in Cohesity Gaia. So we're really optimizing that information retrieval pipeline to really ensure that we're finding highly accurate data that is related to what you're talking about. Again, with the goals of building a very robust enterprise-grade information retrieval pipeline.
Absolutely. And
Thank you for jogging my memory, Nabe.
Welcome. What you saw here, this is already an amazing offering. Will drive a ton of value for Cohesity customers and enterprises across the globe. What's even more amazing is that this is just the beginning, right? We're talking about PDFs, text, and RAG pipelines, but there's definitely more for us to do moving forward. And one of the things that you can think about is if you look at all the data that you have on your enterprise storage, it's not only PDFs, not only text, not only docx files, it's also videos, it's images, it's recordings, and more. So we want to leverage all of that data and generate intelligence, generate insights, and take action, connect to agents that can use that material to create more, to manipulate, and to add value to the enterprise. And this is where we're going next, right? Extending the multimodality umbrella to more than just PDFs. We're talking about ingesting audio with the Nvidia Nims, our speech-to-text models, and translation models. We have new models coming up for image and video ingestion with visual language models, and a lot of other cool techniques that we have to optimize that pipeline. And also we have all the unstructured image in the meaning of pictures of dogs, of products, and other types of animals. All of that, we want that to be embedded as well, so we can retrieve relevant products, recommendations, and other use cases for the enterprise. And all of that in a single pipeline that you can leverage for different use cases, different agents, and different mechanisms. So this is the start of a great partnership, great ecosystem that we're building together, and will grow more and more.
No, I'm really excited to start chatting about pictures of dogs. As we start to, as we were kind of looking through a longer lens on what does AI mean for Cohesity, because again, we have this goal of creating the world's most robust information retrieval pipeline to pair with AI, ML, and generative AI capabilities. We took a step back and wanted to kind of create a vision around Cohesity and AI. Now that we have a generative AI application that we released, Gaia, which, if you guys didn't realize, Gaia stands for Generative AI Application.
I did not know that. It's the first time I hear that.
We're a bunch of engineers, and so that's what we decided to name it. So at Cohesity, we really wanted to create this umbrella term of Cohesity AI and fold all of the artificial intelligence, machine learning, and generative AI workflows across the company under one cohesive, to borrow a pun, umbrella. And this umbrella term kind of supports three core pillars, and it's platform, insights, and ecosystem. And we'll run through these really briefly, but it'll show you where we're going and why the partnership with Nvidia is so important. First and foremost is platform AI, and it's AI that we use to take care of our customers' data and offer operational intelligence. Next is insights, and we spent some time talking about this. This is where Cohesity Gaia squarely falls in. This is AI that we use to create rich insights stored on the platform. And then there's something of a little bit more future leaning and a little bit more future lensed, and it's the ecosystem. This is providing the tools, platforms, and services to our customers to deliver AI to their business. You know, I think if there's one thing that you can walk away from this talk is data is what powers the next generation of AI, ML, and Gen AI. And so being able to provide a seamless platform to deliver that data into those is paramount. And if you think about from a platform perspective, this is stuff that we've been doing actually since 2015, 2016 with our anomaly detection, ransomware detection, data classification, a lot of those things that were in the security pillar that we talked about in the very beginning. And it also brings together some things that we are about to launch around our operational intelligence, bringing the operator of the platform just-in-time information through the powered by generative AI capabilities. From an insights perspective, we don't need to beat this one any further. We spent a lot of time on this, but some of the core use cases we see with our Gaia application are like an e-discovery and compliance assistant, being able to help compliance officers, legal assistants be able to interact with data through the use of natural language, and it actually does reduce their time to overall findings. And then knowledge management, which is what the video we just showed there, being able to sift through hundreds of terabytes or hundreds of thousands of documents and hundreds of terabytes really of data to derive pinpoint accurate insights from questions that are being asked. And then finally, in our ecosystem, this is kind of where I think the partnership with Nvidia is going to start bearing a lot of fruit, is being able to provide tools, services, and platforms for that data so that you, the customers, can bring and deliver AI to their businesses. And this is going to result in data curation, data filtering, because we own the file system, being able to present that data back up to folks like model builders to be able to interact with that data just in time to help build models for their business. Because I think there's an old adage, more data, more better, when it comes to AI. And I think what we wanted to be able to do with a few minutes left in the session is kind of open up for some Q&A. If you guys have any questions at all,
Please raise your hand.
Raise your hand. Thank you.
Thank you.